Okay, the video for week 2 was a little long and it took forever to upload to YouTube, but you know, this time I have 2 different practice sheets, so there'll be 2 different videos showing how to do these problems. The first one is 2.6 and 2.7, and both of them have several concepts that we're going to have to look at. So for 1 through 4 on this particular worksheet, we're looking at how to take 2 functions and do just basic operations with them, adding, subtracting, multiplying, dividing. Now, when it says f minus g, what they want you to do is take whatever f of x is. In this case, it's 3x minus 4. You can put in parentheses just to keep it as a thing. And then you want to subtract whatever g is. In this case, it's 9x minus 6. Also in parentheses. Now, the parentheses are important for minus because this minus sign has to distribute into the second parentheses. So this is what they're asking you to do when they say f minus g. And then doing that, you don't need the parentheses on the first one. Minus 9x plus 6 when you distribute the negative. And now you can combine like terms. 3x, negative 9x, negative 6x, negative 4, positive 6, plus 2. All done. All right, let's try another one. Next one's pretty quick. F divided by g. And you can just write it as a fraction. So 3x, well, no, it's a different problem now. So 9x, squared minus 5x is f. And then g is x squared minus 3x minus 10. With dividing, if you're not going to get into the whole long division with polynomials thing, or which I don't want to, then the only thing you can do is factor both the top and bottom. So if you factor the top, it's a GCF problem. Only x can be found in both 9x squared and 5x, so just pull it out and then divide each one of them by x. That'll leave you with 9x minus 5. Down here, if you want to factor, this is a trinomial, and so we're looking at 2 numbers that add to give me negative 3, but multiply to give me negative 10. Or another way to think about it is 2 numbers that multiply to give me 10 and subtract to give me negative 3. That's negative 5 and positive 2. So that works for both. So this becomes x minus 5 and x plus 2. Now notice that there is nothing that cancels, because you're not allowed to cancel anything until after you factor. That is something you have to remember. And if that's the case, then nothing cancels, and there was no point to even factor this. So this is an answer, whatever you want to put. I'd put this just because. So really, there's not much to that problem. Now, it might have been able to factor and cancel, in what case you would have had to have done that. But in this case, you didn't. All right, f plus g, a little nicer. Very similar to f minus g. You take whatever f is, which is 4 minus 5x, you can put it in parentheses if you like, plus whatever g is, which is negative 8x plus 5. That's for number 3. And here, there's no minus sign to distribute, so the only thing you have to do is combine like terms. Negative 5x and negative 8x is negative 13x. Positive 4 and positive 5 add to give you positive 9. And we're all done with that. And then number 4, you're asked to find fg, which is actually f times g. Maybe you already knew that. I just wanted to make sure. So here, you need the parentheses again, 5x minus 2. You need them. And then the next one, you got 6x plus 3. So what this does is it creates a binomial multiplication situation where we FOIL. So 5x and 6x is 30x squared. 5x and 3 is 15x. Negative 2 and 6x is negative 12x. Negative 2 and 3 is negative 6. Yeah? And then you combine like terms. 30x squared plus 3x, they're different signs we subtract. Keep the larger number sign. And then bring down the minus 6. No need to factor that guy. There's nothing to cancel. There's not a fraction, so you don't have to worry about that. Just leave it the way it is. Okay, so that's 1 through 4. Add, subtract, multiplying, dividing with functions. 5 through 7 asks you to do composition. Now the composition is also known as the fog. And what that is asking you to do is take whatever f is, in this case is 5x plus 15, but instead of an x, put an open parentheses. And what this does is it creates a situation for the first function where instead of x, we're going to replace it with something, like when we were evaluating on the previous worksheet, 2.1 through 2.4. So now what the thing you're going to replace this x with is whatever g is. So g is going to go here, and g in this case is 5x minus 1, right? So you put an open parentheses for x and f, and then you put whatever g is inside the open parentheses. That's what the fog is all about. Now the only thing you left to do here is distribute and combine like terms. 25x minus 5 plus 15. These two will make 25x plus 10. Right? Different sign, subtract. Yeah. Number 5. Number 6 asks you to do it in the other order, the Goff. So here we're going to take g and we're going to write it but with a parenthesis. So that's 5x plus 8. That's what g is. And then whatever f is going to go into here. So that ends up being negative 4x plus 2. And very similar to this problem, we just distribute and combine. Negative 20x plus 10, and then bring down the plus 8. And then combining those two, they're both positive, so we add, we get negative 20x plus 18. All done. Don't worry about number 7. It's not on the quiz, and it's, let me think if that's going to be a problem, actually. Actually, it's not too bad. Number 7 is not too bad. If it's the Goff, it's not too bad. You just write 2 parentheses minus 4, and then you put in that trinomial into the parentheses. Again, distribute, combine like terms. But if it was the other way, if it was the fog for number 7, it'd be a little bit more complicated, a lot more work. So, but anyway, number 7 is not on the quiz, so I'm just going to skip it, along with 8, 9, and 10, because you don't need to know about that either. Moving on, number 11. Isn't this fun? We're going to find the inverse. So with inverse functions, we're basically doing the opposite of what we see. So we see negative 8x plus 8. What's actually going on is we're multiplying by negative 8, and then we're adding 8. And if you wanted to write that in that order, you would say multiply by negative 8, and then you would say add 8, right? If you just wanted to write in English exactly what's going on in this function. Well, the inverse function, which has a little negative 1 as the exponent, and it's not the same negative 1 as the fraction one where it brought you down to the denominator. Not doing that at all. It's just, for some reason, that's what they call inverse. And I don't like it, but that's what it is. Anyway, to find the inverse, all we have to do is do the opposite of what we just wrote down and in the opposite order. So we take x first, and then we're going to do the opposite of add 8, which is subtract 8. And then we're going to do the opposite of multiply by negative 8, which is divide by negative 8. We got to do the whole thing by negative 8. And you're done. So basically, do the opposite of what you wrote, but in the opposite order. There's another way to do it, and I'll show you with this next question, number 12. So f of x is 8x plus 5 over 3. And if you wanted to write this, I would first say you multiply x by 8, that's number 1, then you add 5, that's number 2, and then you divide by 3, which is number 3. So 1, 2, 3, and then when you write the inverse, you would go 3, 2, 1, but doing the opposite. So multiply by 3, subtract 5, divide by 8. But if you don't want to do it that way, or if that way is confusing to you, what you can do is you can pretend like f of x is y. Nothing else happened. And then you can just swap the two letters. Like literally replace y with x and x with y, like this. Now the reason why we're doing that is because to solve for y, the new y, we're going to have to do the opposite to get rid of all this junk around it. And that's exactly what we do when we find the inverse. So the first thing, we would multiply by 3 on both sides, and then they would cancel and be left with 8y plus 5. And over here you got 3x. Now we're going to subtract 5. Now they're not like terms, so we just write 3x minus 5 equal to 8y, and that's gone. And then we divide by 8, because that's get rid of that. And then that'll be gone, and what we'll have is the inverse. 3x minus 5 all over 8. Yeah? So we're basically doing the opposite, and there's two different techniques to do it. This, you're writing in English what's going on, order of operations, in the original function, and then you're just going in the reverse order, doing the opposite. Here, you're swapping the x and the y, and then solving for the new y. So you have to remember how to solve equations pretty well in order to do it this way. I personally like this way, but you know, it's not. I'm not taking these quizzes. I'm just making them. I have to laugh at my own jokes because there's nobody here to laugh at them but me. Isolation is the pits. Number 13, we have x plus 6 raised to the third power. Now, if I were to do it like I did up here for number 11, I would write, first of all, I'm adding 6, so that's number 1, add 6. And then the next thing I do is I'm going to raise to the third power. Third. So how do I do the opposite of raise to the third power? That is root. So the opposite is third root of x. So that's the opposite of raise to the third root. And then I'm going to subtract 6 from that. Now I'm not subtracting 6 inside the root. I've done the root, I'm done doing the root. Does that make sense? So this came first, so I only did it to x. If this had been like number 1 up here and I was doing the opposite, then by the time I got to it, everything around x would all be under the cube root. But because I did it first, going in opposite order, only the x is under there. Nothing to do. You're all done. Right? So finding inverses aren't too bad, right? Number 14. F of x is square root of x minus 8. So the first thing I do here is subtract 8, and then take the square root. Now what's the opposite of square root? It's raising to the second. So I'm going to say x to the second, and that is the opposite of square root. Because this is actually a little 2 up here. Oop, there we go. It's just invisible. So it's kind of this very similar to this, raising to the third cube root. Square root means raised to the second. They're opposites. So because that came first, I'm only doing that to x, and then I'm going to do the opposite of subtract 8, which is add 8. So if you do it this way, and you're likely to look at this word to tell you what to write next, if you wrote minus 8, not thinking, then what you should do is you should definitely off to the side go, okay, number 1 is raised to the second, and number 2 is add 8, without looking at this part right here. So we're just saying, oh, here's the original, and here's the inverse, and then scratch through the original, so that you're only looking at this when you write what you write. Okay? It's just a little thing that'll help you in case you make mistakes sometimes in your head. I don't know if you're like that. Okay. Does a graph have an inverse function? So with graphs, again, they're not on the quiz, so you don't have to worry about it too much. But I want you to see that there is something called the horizontal line test. And the horizontal line test says that if a horizontal line hits it more than once, which this one does, then it does not have an inverse function. It has an inverse, but it's not a function. Does that make sense? Again, asking questions to nobody. So the horizontal line test on this one, number 16, means it only crosses it once no matter what, because it's never quite horizontal here. It gets closer and closer, but never quite there. So basically, no horizontal line hits it more than once, and therefore, it does have an inverse function. And that's it. So Be on the lookout for 2.8 next.